Welcome to our comprehensive introduction to multimodal model fine-tuning. In this course, we'll explore how modern AI systems can process both images and text together. The diagram shows the fundamental concept of multimodal learning, combining visual and linguistic understanding into a single model. This is an exciting field that's rapidly evolving and has numerous practical applications. These learning objectives form the foundation of our module. We've structured the content to build your knowledge progressively, starting from basic concepts and moving towards practical applications. The concentric circles in our visualization represent this layered learning approach. We'll start from the outer circle of basic understanding and work our way to the core concepts. Our course follows a logical progression through 6 main topics. We'll begin with the fundamentals of multimodal learning before diving into specific architectures and their capabilities. As we progress, we'll explore the current landscape of available models and understand when and how to apply fine-tuning techniques. Multimodal learning represents a significant advancement in AI, moving beyond single-type data processing. Think of it as teaching a computer to understand the world more like humans do, by combining different types of information. The circles in our diagram represent different data types, and the connecting lines show how these modalities interact and inform each other. This integration allows for richer understanding and more sophisticated AI applications. Let's examine the architecture of vision language models. The key components work together like a well-orchestrated system. The visual encoder processes images into a format the model can understand, while the text encoder does the same for text. The cross-attention mechanism acts like a bridge, helping the model understand relationships between visual and textual elements. Finally, all this information comes together in a joint embedding space where the model can reason about both modalities simultaneously. The field of multimodal AI is rapidly evolving, with several major players releasing powerful models. Each model has its own strengths and characteristics. The visualization shows relative model sizes and capabilities, with the width of each bar representing the model's parameter count. These models represent different approaches to multimodal learning, offering various trade-offs between performance, size, and specific capabilities. The decision to fine-tune a model isn't always straightforward. We need to carefully evaluate several factors. The decision tree in our visualization represents this process. Consider fine-tuning when your specific use case requires customization beyond what pre-trained models offer, but remember that fine-tuning requires significant resources and high-quality training data. Sometimes, using a pre-trained model might be more efficient and cost-effective. Fine-tuning builds upon pre-trained models, adapting them for specific tasks. The layered structure in our visualization represents how fine-tuning works, starting with a pre-trained base, adding fine-tuning layers, and finally including task-specific adaptations. Understanding concepts like PFT helps optimize this process, making it more efficient and effective. Evaluating whether to fine-tune requires a systematic approach. Our pentagon diagram represents the 5 key criteria to consider. Each point represents a critical factor that influences the decision to fine-tune. We need to balance these factors carefully to make an informed decision about whether fine-tuning is the right approach for a specific use case. Understanding the terminology is crucial for working with multimodal models. These terms form the foundation of our technical discussions. Zero-shot learning refers to the model's ability to handle new tasks without training, few-shot learning involves learning from minimal examples, and transfer learning leverages knowledge from one domain to another. Cross-attention and embedding spaces are key architectural concepts, while PFT represents modern efficiency techniques. As we conclude this module, remember that successful multimodal model fine-tuning requires balancing theoretical understanding with practical implementation. The interconnected circles in our visualization represent how theory and practice must work together. We've covered the fundamental concepts, current landscape, and decision-making framework needed to begin working with these powerful models.